So taking a look at this last problem, painter A and painter B can paint a wall in 10 hours when working together. So I know that this 10 hours right here is the amount of time that they spend working together. It says right here that painter B works twice as fast as painter A, which means that painter B is the faster painter. How long would it take each of them to paint the same wall if each painter worked alone? So if I keep track of this, I know I'm going to need their names. I know that I'm going to need their alone time. Their alone time will also be able to tell me what their rate of work is. And then we know what their work time is. And then I know that I can get their work if I know what their rate and their work time is. So taking a look at painter A and painter B and kind of organizing all of this, I can say the alone time is what they're actually asking me to find. So I know that there are different amounts of alone time. So let's see. In this case, because painter B is the fast painter, I'm going to actually have him be X because we already know that it takes twice as long for painter A. So if you think about it, if this is 5 hours, this is going to be 10 hours. If this is 6 hours, painter A is going to take 12 hours. So the alone time for painter A is 2 times whatever painter B's time is. Now, what that means about the rate is always the reciprocal of the alone time, so 1 over 2x, and for painter B, it's 1 over x. Then the work time, it says right here that they spend 10 hours working together, so I can just go ahead and multiply these by 10. And then when I take work, remember the idea for work is work equals rate times work time. So taking a look here, this case, work time is 10 times rate, so that's going to be 10 over 2x. Now, just to make these numbers a little bit smaller, I'm going to go ahead and simplify that and say that that's really 5 over x. Then taking a look at this one, I can see that this is going to give me 10 over x. I know that the work equation always says that you add the work that each person does together. So there's my work that each person does added together, and that will always equal 1 job. Now, taking a look at this, these already have a common denominator, but this 1 doesn't look like a fraction that has a common denominator of x. So I'm going to change this and say, looking at that, I can say that this is 5 over x plus 10 over x equals 1 over 1. Well, I want this green 1 over 1 to have a denominator of x. So 1 times x on the bottom would get me what I want, but whatever I multiply the bottom by, I have to multiply the top by. So taking a look at what this is going to turn into, I'm going to get 5 over x plus 10 over x equals 1 times x is x over x. Now that this entire blue equation has the same denominator across the entire equation, I know that I can just go ahead and block it out and completely ignore it. And for some reason, my computer screen just wants to keep having some issues tonight. So taking a look here, trying that one more time, much better. What this does is it shows me that I can go ahead and just get the equation that I see right here of x equals 10 plus 5. So if I rewrite that as x equals 10 plus 5, what that tells me is that x is equal to 15. Now, I'm not done with the problem. I have to go back up into the table and say, well, wait a minute. If this x right here is 15, that means that this amount of time right here is 30. So painter A takes 30 hours alone. Painter B takes 15 hours alone. Now that I've actually put these back into the context of the story, I can say that I have completely answered the problem, so I'm going to highlight this and say that that is my final answer.